next speaker is Mr. Amir Kashi, a lead AI and machine learning engineer and product owner with over a decade of leadership experience in UK tech forums and international consultancy, specializing in multilingual chatbots, algorithmic trading, and AI-driven forecasting. Mr. Kashi has led major AI projects using tools like LangChain and Azure. His talk, Revolutionizing Clinical Psychology, How AI is Transforming Diagnosis and Therapy, will showcase innovative applications.
Thank you. Hello again, and thank you, Sabo, for introducing me. And also thanks to Dr. Banki and Dr. Hamid Rahmani for inviting me to this seminar. Good afternoon to the people who are joining in Iran. I think it should be around 2 o'clock. And I hope that you have enjoyed the talk. I've enjoyed the talk so far and learned a lot. And in the next 30 minutes, I will share some of my experience and some of my findings about the AI and how it can transform the diagnosis and therapy. Before that, I would like to ask everyone if you can turn on your camera for a few minutes, if you're happy with that, just to make sure that I'm talking with real people. I know that we are living in the era of AI and VR, but it's good to see your faces. Okay, thank you everyone for those who turned on the camera. Right, just a little bit about myself. My background is in engineering and science, so I don't have a background in psychiatry. But I have tried to understand the terminology in this area and see that the areas that the AI can help, is helping at the moment or has the potential to help in the future. I will be happy to answer the questions which are more related to the AI. When it comes to the psychology, maybe I'm not that comfortable. But yeah, I might ask the doctors in this session to answer those kind of questions if you have any. Right. So what we are going to do, the purpose of this presentation, I want to go through the AI concept for the psychologists that might have limited technical background in this area, and exploring some current and emerging AI applications in clinical psychiatry. Some of them are currently used, and there are some emerging technologies which has the potential to change the future, and providing some practical guidance for incorporating AI into clinical practice. That's the purpose of this presentation. And why it matters, you know better than me, people with mental health disorders are around 1 billion in the world, and there's a shortage of qualified mental health professionals. And AI has the capability and has the potential to extend the reach and effectiveness of the care. And there's one question which I want to ask everyone to think about that. If you want to talk about it now, feel free to do so. But otherwise, just keep that in mind, which in my view, this is a very important question. Will AI increase or decrease the inequality in the world? And we can ask this question from about any technology. Think about the internet. We have the internet for the last 20, 30 years. Has it increased or decreased the inequality? Or with the transportation system, or with any technology, we can ask that with the communication systems. And the same is true about the AI. This is a valid question. And by the end of this presentation, I won't answer this question now, but by the end of my presentation, you will find what I think about AI. Will it increase or decrease the inequality in the world? And the topics that I'm going to cover is just reviewing some AI fundamentals, diagnostic support, how it can support the diagnostic, the future possibility, the therapy applications, cognitive training, and ethical consideration, which always come to the mind when we are talking about AI. And AI in psychiatry represents one of the most significant transformation in mental health care in recent decades, which again, by the end of the presentation, I hope that I can convince you about that. Right. About the fundamentals of AI, what is artificial intelligence? In a very simple words, these are the computers that are designed to perform tasks that typically require human intelligence. Something like learning from experience, or recognizing the patterns, understanding the language, making decisions, or solving problems. These are the things that needs a level of intelligence. And this is different from traditional computing. We had the calculators or the computers from 50, 60 years ago. They can do some calculation. They can follow the procedure that we define for them, but it's not intelligent. Learning from the experience requires a level of the intelligence. For example, when you have a child, you show them dogs. You have a 2-3-year-old son or daughter, and then you show them, okay, these are the dogs. You show them 10 dogs, and then they realize, okay, this is dog. And then when they see a new animal, they will understand, okay, this is new. It's not like any other previous 10 dogs, but they can understand, okay, this is a dog, because they learn the pattern, and based on the experience, they can learn. Or learning the language. This is very, the field that requires a lot of intelligence, because the language is not talking about the numbers, adding, multiplication, or calculation. It's understanding the meaning of the words, which needs an intelligence. And with the artificial intelligence, the computers are able to have a level of that kind of intelligence. You have seen the ChatGPT, you have seen the, for example, image recognition. You take a photo and it can identify, okay, this is a photo of that person, or this is a photo of a tree or something like that. These are the things that artificial intelligence is doing, and it's getting better and better over time. I covered this a bit, the differences between the traditional software and the AI systems. In the traditional software, it follows explicit programming and it has fixed responses to the inputs, but has the limited adaptability. But in the AI systems, they can learn patterns from the data. As I said, you show them some dogs, and then it understands, okay, this is a dog. You show MRI images with people, for example, with cancer, and it can identify, okay, this is the pattern that can happen in the MRI images for the people who have cancer, for example. Or any other data that you can show. It can be sensory data, some, for example, the heart rate, the sleep pattern. Those data can be fed to AI systems, and then they can learn from those data, find the patterns, and learn from the experience. How it is relevant to psychiatry. You have lots of data in the psychiatry. For example, the medical record and diagnosis tests, these are some data. You have loads of previous patients, and all of the data has been recorded. What was the problem? What was the symptoms? What was the solution? And all of that data is available. We can show that to the computer. Okay, these are the data, these are the experience, read them, find the pattern, and learn from them. Speech patterns and linguistic markers, for example, for some mental health issues like the dementia or ADHD, there are some symptoms in the speech patterns and linguistic markers. And again, AI can learn from the previous data to apply that for a new patient. Another source of the data is behavior and cognitive patterns, or facial expression and emotional cues. So these are the things that can be used as a source of the data for training the AI models. And now we come specifically to the field of the generative AI. The generative AI is AI system which can generate new data. For example, generating a new text, like the ChatGPT that you have seen. So it has seen all of the text on the internet from the different languages, from English, Spanish, Farsi, Arabic, in all of the languages, and has learned the pattern of those languages. And then it can generate new text. It can generate new images, new audio or video, and it can create novel outputs based on the patterns in the training data. It's not just repeating the training data, it is creating a new data and can produce human-like responses to the prompts. This is the area of the generative AI. And when we talk about the LLMs, this is the large language models, which is, again, a subset of the generative AI, which focuses on the text. How it can be applied in for clinical applications. For therapeutic dialogue, it can engage in the supportive conversation. I can show you one example in the later slides. For the clinical documentation, that's everyone that goes to the NHS will consider that. You go to your GP, you talk for 10 minutes, and then the GP should spend maybe 30 minutes, or I don't know how much time, just to document what you have said and what they have said, to have the recording. But the AI can do that, to document everything and make a summary of the conversations. For the information synthesis and psychoeducation, it can be used in the education as well. One point to notice here is that the large language models are tools that augment the professionals. They are not meant to replace the professionals, like what Garcia just mentioned in the previous talk. The professionals who use this technology will be more equipped and can do their jobs better and faster. But it's not the goal to replace the clinicians and the psychiatrists with the AI. Okay, just going to some applications which are currently available. One current application in the therapy is using chatbots. You can think of, you have used the ChatGPT, I'm sure everyone has used that. But you can think of that as a ChatGPT which is customized specifically for the therapy. You can give some books or articles or some instructions to the ChatGPT and telling that, okay, whenever someone asks a question or wants to engage in a conversation with you, you should follow these instructions. For example, in the beginning, you should ask their symptoms. They should tell them, I'm AI, and at the end of the day, you need to go to see some person. You can give some instruction to that AI and then customize that ChatGPT for the therapy applications. And obviously, there are some advantages of that. It has 24/7 availability whenever you want. You can use that chatbot. It can track your engagement, the interactions that you had with the chatbot. This is the thing that the computers are very good at. They can keep record of the things and monitor the progress. And there are some studies that shows this is specifically for this product called Terabot, which Garcia also mentioned in his presentation. And this is a kind of a chatbot which people can use that. And the study shows 78% of the users reported improved skills coping with the situation. And one other statistics here, which is important to notice, is about the ratio between the therapist and to the potential patient, which is 1 to 340. For every 340 patients, there's just one therapist. And I can imagine that one person cannot work with that amount of the people. But having these AI tools can help them to work better. So this is one example of the conversation with the Terabot. So I've said I've been feeling really overwhelmed lately. Work is stressful, and I can't seem to relax even when I'm home. So it doesn't respond me straight away, it asks me some question that sounds challenging. When you're feeling overwhelmed, your body and mind can stay in heightened state of stress. So some information to show some sympathy. And then it asks me a question: have you noticed any specific physical sensation when you're feeling this way? And then my heart rate races and I feel tense all over. Sometimes I get headaches too. And then, okay, those are common physical responses to stress. Would you be willing to try brief relaxation? So it starts to engage with me and guide me to how I can manage this situation. This is something that a therapist might do in the earlier stages of the conversation. And obviously it
Very
can.
sorry, Mr. Kashi.
Yep,
Sorry to
sure.
interrupt. We do not have your picture. I think that's. Could you please turn on and off your camera?
Oh, yeah. Okay, can you see me again?
Yes,
All right,
yes, thank
thank you.
you. Sorry.
No,
Thanks.
no worries, no worries. Yeah, I have this issue with my laptop. Sometimes the camera decides to turn off. But yeah, thank you for letting me know. So this system, as mentioned, it's meant to augment the practice, not to replace. And what it can do, it can give some between session support. So you go to the therapist every, I don't know, every week, every 2 weeks, but in between those sessions, you are engaging with the AI, and it can help you through that period of time. For the homework compliance, for tracking your progress, and it is useful. And also it gives a dashboard to the therapist. When you go back to your therapist, it has a dashboard which can see your previous interactions with the AI, what you have asked, what they have answered, the thing that you have done. It can see a summary of all of the engagements, which can help the therapist to do their job quicker and better. Oh, sorry, did I turn it off again? Sorry, that was my fault this time. Right. And this is a hybrid model which uses the potential and the advantages of AI with the humans, and combines both capabilities to provide a better service for the end user. Again, another application in the diagnosis is the digital phenotyping, which is again, I think it was mentioned by Dr. Faith in the morning that we are using smartphones. We have some wearables like the smartwatch, and they have lots of sensory. They are gathering lots of sensory data from us. How we are interacting with the smartphone, how we are using the keyboard, when we are talking, how do we talk, the speed of our talk, or the vocabulary that we are using. They can monitor all of that. And there are some symptoms in, for example, in our speaking or the vocabulary that we are using. There are some symptoms that can show, okay, I might have dementia, or the earliest stages of the dementia, or the ADHD. This is very difficult for the humans to do, but for the computers, it's dead easy, because they can just record all of your voices, for example, and then track the number of the words or the volume of the vocabulary that you have over time. And by comparing that, they can find the earliest stages of some diseases. There's another study in the University of Missouri, which just uses this kind of data for the diagnosis. I put the references at the end, but it has shown that these AI-powered systems are relatively accurate. They can predict the progression for the mild cognitive impairment for Alzheimer with the 78% accuracy. And the advantage of that is not only the accuracy, but it is the fact that they can find the problem in the earlier stages. Without it becomes more severe, they can just find that. Decision support systems, again, using this data. I think I need to go faster. I just have 10 minutes for my talk. So again, another applications of AI in diagnosis. There are some research that shows that how they can support the doctors. especially, for example, when it comes to the remote monitoring systems, they have a continuous assessment of the patients. A doctor cannot be with you all the time, but your smartphone and smartwatch are with you all the time, so they can have a continuous assessment and can give the early warning systems. So I go a little bit faster here. Another example is in the ADHD support diagnostic. There are some systems that can monitor the behavior of the patients by the computer vision with the machine learning models. Again, gathering the data in terms of the images, the video, the voice, and all of that, and find some symptoms of the ADHD in the earlier stages. Again, there's another study which shows with a different, these are the machine learning models, the XGBoost, Random Forest, LightGBM, these are machine learning models. They all show high accuracy in that field of over 98%. And they are combining different source of information, the neuropsychological data, physiological data like the heart rate or the sleep pattern, and the behavior data like the speak and those things, or the movements, and combining all of the information to find the ADHD symptoms. Again here, using machine learning and AI, so they are reviewing the patterns of the behaviors. I think it was mentioned previously as well. Just one thing which is important, comparing the traditional versus the AI enhanced assessment. In the traditional assessment for the ADHD, it was, and it is, subjective rating scales. It needs some clinical interviews and observational assessment, and it's paper-based cognitive test mostly. You're more familiar with that. There might be some other ways, but generally it is subjective and needs some interviews for diagnostic the ADHD. But with the AI enhanced, this is objective because it uses some data, and with the same data, it always gives the same result. It's quantitative performance analysis and has pattern recognition across the different data sets. And it can use multimodal data integration, not only the voice or not only some test, but also all of the behavior of a person can be integrated in the AI model. So there are some limitations in the traditional assessment and some advantages in the AI enhanced assessments. But again, the optimal approach is not only relying on the AI. The optimal way is using the clinical expertise with the AI enhanced assessment. So we gather the information, we analyze them with the AI, and at the end, we give a very nice report to the clinicians, to the psychiatrists, and they can analyze all of that, and they can use that as a new source of the information. Combined with their experience, they can do the diagnosis of the ADHD. Similar studies has been shown the power of AI in detecting the dementia. One study shows that based on the speech and language analysis only, they can predict the dementia with the accuracy of 78.2%. And the prediction time frame was 6 years, meaning that there is a potential to have dementia in the next 6 years. And in this specific study, 166 people have been involved. So what they do, they are monitoring the linguistic changes. For example, grammatical simplification, if we are using more simple grammar in our speaking, or the vocabulary restriction, or semantic impression. These are the signs that, as I said, the AI and the computers are very good at. They can monitor those kind of data over time, and based on that, they can identify the dementia at the earliest stages. The advantage of the method is non-invasive assessment and can be performed remotely and relatively inexpensive, and it has the earlier detection potential. I just want to mention something here which is very important to me. You might have heard about the driverless cars. This is the the new technology, and there are lots of funding going to driverless cars. I was thinking why it is that important and why people are spending that amount of money on this technology. But when you think about it, when you think about it, when you create one driverless car, and if it is safe to use, then you can repeat that on the millions of cars with a very low cost. This is the advantage of the software and the computers. When something works, you can copy that easily in millions. And the same is true about the, for example, using AI in dementia or ADHD detection. Once you have an AI system which is good at detecting the dementia, and then it passes all of the tests, then you can copy that in millions of copies. You can make a mobile app, and then everyone can download that and use that. So billions of users can use that. And it makes that service and that thing very accessible for the people. Right. Again, some more slides I have here about the dementia using the multimodal neuroimaging analysis, using the MRI images. Again, AI is good at understanding the images and image analysis, not only the normal images, but also the CT scans and the MRI. It can use those ones to detect the early symptoms of these diseases. And so it can give us some preclinical detection before going to some standard kind of systems for detecting these things. AI can do some pre-detection, and it can give us some personalized risk assessment based on the behavior of the different people. Again, this is another study which shows the use of AI for dementia detection. And this is very important, specifically in America. It says that Alzheimer's diseases are expected to be doubled in the next 30-35 years by 2060. So detecting those kind of diseases is very important in the earlier stages. I briefly touched these ones, augmenting what the therapists are doing. So it's not only using the AI, but combining the AI with the experience of the psychologist. They can use the cognitive behavior therapy and use the data for AI, and it can give some personalized treatment recommendation. I just go a bit quickly here. Maybe going just to, sorry about that. I will share the slides with everyone after this talk, but I just wanted to come to the future possibilities. So I just show what is done at the moment, what is available, but there are some more things that can come in the future. One of them is the multimodal AI systems, which not only uses one mode of the communication, for example, in the ChatGPT, in all of the chatbots, the communication is basically based on the text. But multimodal systems can combine different channels, for example, the speech, the visual processing, the facial expression, physiological data. They can combine all of them. At the moment, this is under the study. There is no product in the market which can combine all of that, but it is very achievable in the future. Another thing which is some universities are working on that is the brain-computer interfaces. That technology was there; it's not new. For example, monitoring the EEG signals to find the early symptoms of some mental health issues. But with the combination of the AI, it's becoming more achievable and more accessible for everyone. Getting those information from your brain, and then the AI can understand that, analyze that, and also give a feedback to the system, which means having a closed loop system that adapts in real time to neural activity. You get some EEG sensor data, and then the AI analyzes that, and then it can stimulate the brain. These are not, might not happen in the near future, but probably in next 10 years they might happen. Another thing is predictive analytics for treatment. Again, once you have the data and you are monitoring some behavior of the people, then you can predict what can happen in the future. So at the moment, there are some basic prediction models, but in the near future, it is very possible to have some multimodal data analysis. In the medium term, you might have some systems which work real time. And then in the long term, we might have some preventive intervention or precision psychiatry. Some research directions in the future is genomic integration, cross-cultural AI, which was mentioned by Garcia as well. In the different cultures, you have different kind of way that the people show some symptoms, or the way that they communicate. In some cultures, the facial expression are more important. In some other cultures, the language is more important. And having an AI system which can work across the different cultures is another research field. And also the embodied AI therapies and neuroplasticity optimization. These are the other research fields at the moment. And we have, I have a couple of slides on the ethical consideration. It always comes to mind when we are talking about the AI, the privacy and data security. And I always say that the AI systems are as secure as your email or your WhatsApp. Whatever data that you normally use email for sending or receiving them, you can use AI with this. You can put that data in the AI. If you don't trust your email or WhatsApp or any other online service, then you cannot trust AI. But if you trust them, you can trust the AI as well, because the security, for example, on the Azure services, it's as secure as the other services. So there's no data breaching. Transparency is another consideration. When someone goes to a doctor, they can explain and they can say that, okay, why I have come to this conclusion. With the AI, it's kind of a black box. It was a black box, I should say. But nowadays, it's more becoming more explainable. When AI gives an answer, it can describe why I have come to this conclusion. But again, this explainability is another consideration. About the bias and fairness, which I think there was a question from Garcia in the previous talk about this topic. This is very important, the bias and fairness, and the solution to that. There are ways to mitigate the bias and fairness. We can actually manually feed the data from the different cultures, from the different group of people. So not only focusing on the Western hemisphere, you can use, for example, the data from Southeast, from the West Asia, to include all of the cultures and all of the situations. And at the end, human oversight is important. We cannot make the final decision with the AI. Always a human should be there. And again, I always say that, you know, with the airplanes, they are autopilots at the moment. But if you're told that this airplane that is going from London to Paris, for example, it doesn't have any pilot, it just works with the autopilot, I think no one wants to board on that plane. Because at the end of the day, we want to see some human to be in place to make the final decision. And that's the same in using AI for the mental health. And finally, the clinician role. Again, it was touched with the previous talks. You might think, okay, if the AI is coming, what is the role of the clinicians? The thing is that the AI is assisting and augmenting the role of the doctors, and it's not going to replace them. And the training needs for clinicians, they the doctors and the clinicians need to learn AI literacy and the data interpretation. They need to learn how AI works and how they can interpret the results of the AI. And in that case, they can have a better and faster, they can do their job better and faster with this help of the AI. So we can say the clinicians are always at the top in this area. The patients are at the center, but we are using AI around that to gather the information, analyze the information, summarize that, give that to the clinician, but they are the people who make the final decision. And always when it comes to the role of the people after the AI or losing the job, I always mention this book from Bertrand Russell. This is my favorite philosopher. His book, In Praise of Idleness, he says that giving the work to the machines, this book was written after the Industrial Revolution. And it says that giving the work from the people to the machines is not a bad thing because people will have more free time for enjoyment. And the same is true with the AI. AI can do some repetitive tasks. For example, making a note of a meeting or summarizing a meeting. This is not a thing that we can be proud of doing that. If a machine can do that better than us, faster than us, why not? And but when the machines and the AI help to do those things, then we can focus on more interesting things. And finally, some practical recommendation. Start with augmentation, not replacement. And the roadmap for implementing any AI system in the mental health diagnostic and therapy processes is having some assessment, what areas can have the potential to use AI, and then do some education, develop AI literacy and understanding of relevant technologies, and do a pilot testing. Start with a small scale implementation, use some AI for some specific small tasks and get some feedback. And once it works, then gradually incorporate the successful tools into regular practice. So this is a kind of implementation roadmap for AI systems in the mental health. Right, I think let's leave the other slides. I just have a few more slides here, but I'll stop here and give some time for the Q&A.
Thank you so much.
Thank you for listening.
Thank you so much. We have quite a few questions. The first one is, can AI multitask as humans do?
I'm not sure that we as the human do the multitasking, because there are some studies that says that we are doing them in a series, not in parallel. We do a bit of this task, a bit of that task, a bit of that task, and then come back to that. And the same is true with the AI. If I know the context of the question, I might be able to answer better, because the different things comes to my mind. Just to give you a very short answer on that, the chatbots that we are using in behind the scene, they are connecting to different sources. And when you send a question, multiple agents are working in parallel to give you the answer. For example, one agent goes to the web and does a web search. One looks at the previous data. One looks at the, I don't know what, another source. And one agent is working on the accuracy of the data, and at the end, it will show you the final answer. If that's meant by the multitasking, yes, the AI is doing that to some extent.
Thank you. Another question is, how confidential is the information we share with chatbots? I know it's currently forbidden to share identifiable information with them, but are there any approved or secure bots available for this purpose? I think you touched on that a bit, but could you just...
Yeah, it depends actually the service that we are using. For example, for the ChatGPT, the free service is not completely private. It's private between you and OpenAI. but OpenAI has access to all of your chats and what you've put there. If you use some paid services, there are some ways to make it completely private. The default setting in, for example, in Azure is that they keep the data for 30 days. But you can have another contract with them, which is a paid contract. And by that, there is a zero retention, which means they won't keep any data on their servers. I hope that answers the question. So pretty much depends to which service do you use.
Thank
And
you.
also, I should mention that you don't have to use these services. There are some smaller services which can be run locally on your computer, and that's completely private. You can disconnect from the internet, just use that software. But it needs a high spec computer to run those models.
Thank you. Next one is, can AI understand and read body language?
Yep, that's another field, interesting field of the study, which is the image analysis and the video analysis. Yeah, it can find the facial expression, for example, when you're laughing or crying or whatever, it can find that, and also the body language with the hands and everything. It can do that to some extent. That was a hot topic 5-6 years ago. I'm aware that many people were working on that one. Recently, I was more focused on the language models, but I'm sure there has been lots of advancements in that area.
Thank you. Another question is, which AI tool is able to read images such as MRI?
Oh, yeah. Again, this is the image analysis. As I said, this is the field was very hot topic several years ago. If you're looking for something available in the market, I'm not sure which model. I know that the OpenAI or Gemini, they have the image analysis capabilities, but I'm not sure how accurate on the MRI images. But there are some dedicated services from Microsoft, which is specifically trained on the medical data, including the MRI images. This is a paid service which is available. Yeah.
Thank you so much. And another one is, there's no argue these innovations are happening, but question is data storage. Will refine a customized AI, even a multimodal AI? Where would the data be stored? And how much data it can keep in mind at any given time?
Right. Again, about where the data is stored, it depends which service are you using. You can run some of these models on your local computer, so everything is on your local. When you are working with some cloud services like Microsoft Azure or AWS, then you can select the geography that you want to have the server, because there are some GDPR rules. For example, in Europe, if you're working with the patient's data, you have to keep that in Europe. So if the server is in the US or in any other country, it's not allowed. But with these cloud servers, they allow you to select which region do you want to put your server, and then they make sure that your data is not leaving that geography. So that is one part of the question. I think the question has had another part. One was for the...
How much data it can keep in mind at any given time?
All right. Again, it depends with the language models. The what it calls it's called the what window, the window size, something like that. With the different models, it's different. I think the minimum size is something around 32K, but there are bigger models which can contain a window size of I think 128 K of words, for example, which is, let's assume it's a kind of a chapter of a book. That's the window size that they can look at it. But Let me, I have some more slides in the appendix. I should show that. You
I'm
know,
so sorry.
yeah,
We have one more minute and then we have to move on to our next speaker. So if we couldn't cover everything, could you please just answer some of the questions that are left in the chat
sure,
box?
yeah. Just to answer this
Sure.
question, you know, these language models have two capabilities. One is the general knowledge from the internet and also some knowledge about the languages. That general knowledge, they at the moment, I think, for example, for the ChatGPT, it covers all of the text data on the internet from the beginning until maybe a few months ago. So it has that knowledge in mind. But if you are feeding some context to your question, there is a limitation to that context. And at the moment, I think it's something like a chapter of a book, that size of the information.
Thank you so much. Thank you for your time.
No worries.
Dr. Garcia, I think Mr. Garcia wants to ask a question.
Sure.
Actually, very quickly, more than asking a question, I wanted to clarify. I can see a lot of questions related to information storage, and I have to clarify that that's not an issue today. Actually, most of the cloud providers, they provide storage solutions that they are HIPAA compliance and GDPR compliance. So that means, by regulations, you can have the servers somewhere in Europe, any country in Europe. And actually the information needs to be stored in a specific, what we call is a schema, a specific format. So that's not an issue. The issue is not about how secure it is, it's just whether you're using the right provider in order to design that application. It's once that you break down the information, you only store information that is not person identifiable information, it's no problem to store all that information, and that is limitless. I mean, when we talk about how much information you can store, we are talking about terabytes of information, and that's like trillions and trillions and trillions of patients' information. So, patients' private information storage, that is not an issue today.
Yeah, absolutely. In terms of the storage, no limitations. But yeah, what I mentioned was, for example, specifically in the language models and the context window that they can use for one specific question. If you want to give a context, you can store all of the data, but there are some ways to manage a large amount of the data when it comes to the application of the chatbots. So we can say technically no limitations. Let's put that in this way.
Thank you so much. Thank you for your time.